Hello. Hi guys, good morning. Welcome back to the video. Ki hal chal? I hope you guys are doing good. In this, we're gonna see problem maximum coins from key consecutive bags. Again, if you don't know, the number of acceptance rate was pretty low, which means it's actually a very good problem. See, it simply says that you are given an infinite amount of bags on a number line, which means that you are simply given a number line with infinite amount of bags, or you can say infinite number line, where each number line element will have a corresponding bag. Now, one bag for each coordinate. As you can see, a number line can have as many coordinates as possible. Here, if you go and see, you have a limit of number line itself, but still, even if you consider that you have 1e9, that's still much higher. Cool. Then some of these bags, again, few of these bags contains some coins. Now, what these coins are? They are simply a 2D array of coins where it represents at which specific range Li to Ri both inclusive. For that range, I have for every bag in this range, again, for example, if I have a range 8 to 10, so if I draw in a number line, then if I draw 8, 9, 10 as the coordinates, on these coordinates I have bags. On every bag in these coordinates I will have three coins. Cool. Okay, this is what this problem is saying. Now again, the segment that coins contains are non-overlapping, which means all these intervals, which means as you can see, these intervals are non-overlapping intervals. It can be something for us to click, but okay, let's see. Now, also, we have an integer k, which is this specific k. I have to return the maximum amount of coins I can obtain by collecting k consecutive bags. So even if, let's say, I plot all the coordinates, I know in this range I have some coins, in this range I have some coins, in this range I have some coins. Now, as a window of size k, any window of size k which can give me the maximum amount of coins, that's what my ultimate requirement is. Based on these two facts, which means this specific fact and this specific fact, let's try to see what all we do. Now, for this fact, when I say that for any range Li to Ri, I have to do a range update. I have to do a range update, and here in this case, the range update is plus Ci. Here in this case is plus Cj. Here in this case is plus Cm. So for range update kind of scenarios, we try to leverage Fenwick tree, segment tree, or maybe a prefix sum technique, which is also called as like line sweep technique. But if you see, then it is usually referred, or it is usually preferred, I should say, when you have intervals which are actually overlapping. Which means if I do a plus 2 here and a plus 3 here and a minus 2 here, then if I want to see ultimately what is the impact, then I take the approach of having a plus 2 in L and on R plus 1 doing a minus 2, having a plus 3 here and a minus 3 here, having a minus 2 here and a plus 2 here, and then doing a prefix sum to ultimately know that for every specific coordinate, what will be the final impact. This is when we use a prefix sum technique. And if you don't know this, you can simply go and watch this video in description. And this will give you an idea of how we can leverage prefix sum technique. But even if we leverage a prefix sum technique, ultimately I will have to take a prefix sum of what? I have to take a prefix sum of the entire number line. And that number line is itself very high. Thus, I cannot leverage that at all. Okay, that is one thing. But then I also realize, okay, I have to choose a window of size k, which means a k consecutive bag, again a window of size k, so that k bags will come up, and then maybe I can keep on sliding my window. So with that, okay, we got the hint of sliding window, but then again we went to the constraints. Sliding window on such a big length is again not possible. But before we move on forward, I hope so you have watched two pointers in sliding window crash course. If not, please go and watch it, else you will not understand anything. Now, so far we realized that we are screwed up because of the time complexity, because of intervals, because I'm operating on intervals, and interval length is something I was concerned about, which is pretty high. So can I do something that I can leverage int? Again, when I say interval, please make sure that I am interchangeably using coins and intervals, because coins itself is a coin on that interval. So primarily, whenever I'm speaking, I will leverage by saying intervals, but make sure that in the code we will refer by coins, because this is what the input problem is. So I realized that I cannot use the actual specific interval values, but interval number of intervals are pretty less, which is 1e5. So somehow I should be able to leverage number of intervals to figure out what my sliding window should do. Now, here I have shown you all possible variations when a window will slide off size k. One possible variation is that the window of size k will start off from a specific start interval. Okay, the window of size k will be in the middle of some interval and in the middle of some other interval. Okay, it can be, okay, it is in the, maybe it is not in the middle of one interval, which means it is in the empty space where no bags is there. When I say no bags, I mean bags with no coins, and at the place where we have a correspondingly bag in the middle. Or one can be that, okay, it ends at a specific interval. These are the four possibilities of how my window of size k would look like out of all these intervals. But now the again issue comes up that I cannot actually, again, here I am leveraging the interval start point. Okay, here I am leveraging the interval actual middle points, which will ultimately obviously increase the time complexity. Here also I'm leveraging the interval middle points, increase the time complexity. Here I'm leveraging the interval end points, which, okay, because see, interval end points are directly linked to the interval endpoints are directly linked to the interval. So that means, okay, I'm leveraging interval here, I'm leveraging interval here, here I'm leveraging coordinate. Now leveraging coordinate was actually the issue for me. So somehow can I get rid of it? Which means, is it even required is the question. Is it even possible? Because see, ultimately, if I remember, or if I know, my maqsad, my primary aim is to actually go and tell me that what is the maximum amount of coins I can take. Now I'm only confused that can I get rid of these two, and I have to prove them that they are unnecessary. How I can do it? So if in these scenarios, just try to think of a very simple fact that you are leveraging this as a pattern. If I shift it a bit left, then you will come here, right? Okay, I can also shift it a bit right. Okay, shift it a bit right, you will come here. Now, in both the scenarios, even if let's say CI is higher, then I will try to take as many CIs as possible. So it is much beneficial that I will take all possible CIs, which means I will start from the CI itself. If you say that CJ is higher, then I will try to incorporate more CJs here. So with this inference, we saw that even if I have some empty elements in between, either I can take all CIs or I can take all CJs, right? There is no point of actually having something like this, because ultimately, again, you might ask Aryan, but what if I have multiple other intervals in between? Okay, no worries. But right now I'm just trying to show that it is always good to choose either one of the intervals, either right interval or the left interval. Why? Because you see, okay, right now this is the corresponding state, which is unnecessary, because if the CI would have been higher, you would have simply shifted like this. And again, it would have been much better if you would have shifted, entirely taken CI. And if the CJ is higher, then okay, take CJ. But again, in this case also, it is much better to take the entire CJ. So that is how we realized that either I should start off from an interval. Again, my sliding window, this is my window. Whenever I say window, a sliding window, because I hope so, you must have watched the crash course. So for my sliding window, okay, where it is gone? Yeah, for my sliding window, I realize either I will start off from an interval or I will end up at an interval, which means my window will either start off from an interval or will end up at an interval. Now, let's take both the scenarios. Either I will start off from an interval or I will end up at an interval. We will take both these scenarios and we will now apply the sliding window approach here. What do you mean by sliding window approach? Sliding window simply says that keep on expanding the window up till the size k, because you know your window size should be k. And again, here the window size represents number of intervals. So basically interval, I can incorporate as many intervals as I want. It's just that the total allowed length should be k. So, okay, I will simply do the same thing, that I will simply try to incorporate as many points or as many intervals in this specific length. Usually what we do, we simply try to expand it. As soon as we are done expanding, we cannot expand much more further. We try to maximize my answer and then we try to shrink the corresponding length, which means, okay, I will shrink the length and then I will try to move forward. But making sure anytime I'm moving forward, I know the next interval will start off fresh from the start of the next interval. So I'll do the same thing, that, okay, I have my I, then I will try to expand my interval, right? I know my k is 14, which means I can take 14 bags. I'll try to expand my specific, specific interval. Now, whenever I'm expanding, I will not go on to individual coordinates. No, if I will go to individual coordinates, that will incur more time complexity. So I will leverage the endpoints to actually go and take as many intervals. Right? Okay, I will take this interval, then this interval, then this interval. As I was about to take this interval, because see, ultimately my maqsad is to take the length k. So if I take the length k, which is 14 bags I have to take, I'm standing at 0, which means I can land at max up till 0 plus 14 minus 1, which is 13. So 0 and 13 will ultimately give me 14 bags. This is, I drew it by having a picture. But how to do mathematically, I will also show you parallelly. Okay, now my ultimate aim was expand. So far I was here. I will incorporate, again, incorporate the thing in what? I have to take the corresponding sum of the coins in this interval. If I ask you, if I give you any specific interval of, let's say, any given length, let's say 0, 1, 2 and then 3. So length here is 4. I say you, okay, the every of this specific coordinate have, let's say, 2 coins, 2, 2, 2, 2. Ultimately, how many coins you will get from this one interval? Obviously 4 into 2, which is 8. That is the same thing I will do also, that for each interval I will get its corresponding impact and will maintain that in my current sum. But then again, the same question, that as I am expanding my window, up till what point I should expand my window? Simply, you know that you have to take all the intervals which are complete, and then there can be one interval which is partially there. Okay, for the partial one, we will handle it separately. For the complete ones, which means that for any, obviously, if I'm standing at I, I'm trying for all possible j's. Again, don't be confused by saying, okay, Aryan, I is this, j is this, it is O of n square. No. If you're confused in this, please go and watch this crash course of 2 pointers. Now, coming on back, we simply realize, okay, we are simply expanding the window. Thus, I will simply expand up to this specific point, which means, okay, complete intervals I'm taking right now. So while j is less than n, and my coins of j, 1, which means rj is this thing, lj is this thing. So rj is less than or equal to my end point, which is I should say li plus k minus 1. Which means up till that point, I will simply try expanding it. If I can expand it, I will simply add in my current sum. I will add this. This is the length. The length will be rj minus lj plus 1 will be the length, and each will give the contribution of cj coins. So total coins which will be given by this specific interval cj will be this value. Okay, and then I will simply keep on trying to go forward as I can, which means ultimately I will reach this specific j. When I reach this j, its end point, which means rj, is 15, which is obviously higher, which means I will stop here. So far in my current sum, I have incorporated the summation of coins of this interval and this interval. But still partial, this interval is still remaining. To incorporate that partial interval, make sure firstly check if the j is less than n, then incorporate the partial interval. What is the partial interval? Just get this length. What is this length? I know the end point, which is called as r. I know the start point, which is called as lj. So r minus lj plus 1 is the length, and the number of coins at each coordinate will be Cj. R is, I will replace it by L0, or I should say Li plus k minus 1. So I will replace it by L0 plus k minus 1, which is Li plus k minus 1 minus Lj plus 1 into Cj. This is the simple thing, which is the partial length. So you got the current sum, you got the partial sum, simply add it to get the total sum for this specific window. I'll add it to get the total sum for this specific window. And then ultimately maximize your answer. Have a variable called as answer, maximize your answer. But now this is the portion when you expanded it and reach the very brim. Obviously, now you cannot go any further in J. So you have to shrink your window. When I say shrink the window, it is a simple two-pointer technique of shrinking the window. But here in this case, I will not shrink based on coordinates. No, I will shrink and go on to the next possible interval. Here, I directly jumped onto the next interval, which means before jumping onto the next interval, make sure to remove the impact of this current interval from your current sum. What I will do, when my I would have been here, I know the impact of this would be Ri minus Li plus 1 into Ci. This is the impact. For this impact, I will simply remove from my current sum. I will remove the impact, and then I will move my I. Here I. And thus simply keep on repeating it and you will get the answer. Now, this was the case when my window starts from here. What if the window ends? Okay, take the same scenario. Let's imagine my eye is moving and now I have to make sure my window ends at this point. Okay, the same thing. Let's say the K is 14, I have to take 14 bags. In that case, if this is the specific thing, I just simply am moving forward, which means, okay, my J would have been here, then it is moving here. In this scenario, obviously, this is a corresponding window. Next time as I moves forward, the window size increases. Here in this case, if my J is here, I have to make sure that this is not the correct window size. I have to remove its impact. I have to, firstly, always make sure I moves first. So I is moving first. Okay, I is moving first. Okay, again, now you might say, Aryan, earlier in this case, I was left, J was right. Now you are saying I is right, J is left. What is this going on? See, this is a simple technique of sliding window. When I is left and you move simply your J. But here in this case, considering you have to put your end and you have to focus on the end interval, right? Your actual window end should end at that specific interval. That is the reason if I put I here, then any other variable, obviously considering it's the end of the window, any other will be the start of the window. So this J is right now handling the start of the window. Earlier, the I was handling the start of the window. That is the difference why these things are swapped. Okay, so now the same thing happens in this case also, that if this is my J, I know this is a current specific window. Firstly, as I am saying current specific window, which means I would have moved my I. So make sure to take the impact of I. Like when I say the impact of I, which means Ri minus Li plus 1 into Ci, just add that in your current sum. This is the current impact of I. Make sure if your J is here, simply remove the impact of J. So when I say remove the impact of J, simply remove it, which means that if your J is here, then Rj minus Rj minus Lj plus 1 into Cj is the impact. Simply remove it. But here is the catch, that you have to remove the partial thing also, right? Because your J is here, ultimately your J will come here, but still this is not fully removed. Your current sum is this specific thing right now. So make sure to partially remove this thing. So if you know that this is, if as I mentioned, this is, if this is Ri, obviously this will be Ri minus K plus 1. If this is Ri minus K plus 1, you have to remove this specific thing. Again, make sure that 6 and 7 coordinate bags will be removed, not the bag at the coordinate 8, because that is already included. Don't remove it. So if I ask you, what is this length? What is this length? This length. If this is Lj, this is, let's say, some R. So the entire length from 6 to 8 would have been R minus L plus 1. But obviously don't include R, because that is, again, when I say include, don't include R. When I say don't include R, I actually mean don't include this R, because this portion, I told you, only 6, 7 will be removed. 8 will still remain there, right? So I will simply remove one. Like this one which I removed right now is actually I removed it because I don't want to incorporate it. Because this thing I'm taking, this specific partial, is something that I'm removing from my current sum. So you will see simply here that R minus L, again there is no plus one because I removed it, into Cj is the partial impact, and remove this again. See, it is a minus. I am removing that partial impact from my current sum. And that is how I can take my corresponding sliding window on the interval. Thus, if you see, I have named it as sliding interval problem, not a sliding window problem. Cool. I hope so you guys got it. Let's see the code with proper, everything. Firstly, I simply sorted, again, sort the simple intervals based on the start values. When this is done, I firstly said that my intervals, or I should say my window, sliding window, will start off from the start of each interval. When I say interval, I mean coins of I comma 0. I will simply iterate on each I from the left side. The j will be on the right side, simply trying to shift forward. And I will help me to shrink, j will help me to expand. Right? Okay, exact same code as what I showed you, simply having a while j is less than n, and you can go forward. Simply keep on trying to go forward. And when this is done, make sure to add or get the partial impact. After getting the partial impact, simply make sure to add that partial impact in the current sum and maximize your result. Before moving on forward and going on, you know that you will have to shrink your window of size. Like obviously you have to shrink your window, which means you have to remove the impact of ith interval. Okay, same way for any segment, when I know that my window, sliding window, will end at a interval I, I will simply say that here my I will be expanding my window and j will be shrinking my window. So for the current window, which has the value current sum, I will first incorporate the ith interval. Then I will remove the all j intervals which are before, right? If you go, which means here I am, okay, where it is gone. Yeah, so here I'm simply removing all the intervals which are before this all the portion I'm removing here in this point. In this specific point, I'm removing all those specific intervals, getting the partial interval, which is also I have to remove, and simply removing the partial interval also. Now again, the code which I actually wrote was pretty not good in look wise. So this is some code I found on Leetcode Discuss, which was pretty good, awesome. So yeah, that's how the good looking code was able to issue. Now, as you can simply see, the time complexity because of sorting was O of n log n. Elsewise, it would have been O of n itself. And space wise, as you know, that sorting will take log n space by default in the languages like C++, Java, and O of n space in Python. But apart from it, there is no such extra space used. So yeah, that is ultimately what we have to do. Cool. I hope you guys got it. If yes, please smash the like button. Again, it's a bit like tedious to make all this, but yeah, it will be very helpful if you guys can like it and comment what you liked. And yeah, if you have any suggestions, I'll be more than happy to take as a feedback.